Welcome back, my fellow programmers. 2.9 Using the Math Class. Our learning objectives and topics are on the screen. I hope you're ready. Here we go. For our first concept, we will be talking about static methods. Our learning objective, call static methods. On the left, we see some code. We are declaring and instantiating an object from the integer class. And then on the second line, we are calling the compared to method on that object to compare the value of that object to the actual parameter of 15. We need to use the object to call that compared to method because we need a value to compare to that parameter of 15. If we looked up this compare to method in the Java API, it would look like a regular method in which it says it's going to return an int, it's called compare to, and we need another integer to compare to ourselves, the object calling the compare to method. This is an example of when we call a method by object. On the right, you see an overloaded version of that compare to method where we pass in both of the integers that will be compared to each other. In that case, we do not need an integer object to call this method because we don't need that integer object's value. We are passing in the two values that we want to be compared to each other. In that case, we don't call this method by object, we call it by class. When we look this method up in the Java API, it's going to look a little bit different than the other method in the Java API in that it has this keyword static in front of it. What we should see from that is that non-static method calls need an object to call the method. This is because the value of the object is important. On the left-hand side, we see non-static method calls where we are declaring and instantiating an object named num1, and we are assigning it the memory address that's returned by the constructor when we pass in the actual parameter of 22. So that num1 object has an int variable that is holding the value of 22. When we do our non-static method calls, we are interested in the value of that object. For our examples, we have num1.intValue that will evaluate to the 22 that is stored in that object. Our second method call, we have num1.doubleValue that will evaluate to 22.0, which would be that integer value as a double. Our third example, we have num1.equals25 that will evaluate to a false because our value of 22 is not equal to the value of 25 that we are passing in as an actual parameter. And our final example is num1.toString, which will return the value of 22 as a string. On the right-hand side, we will see some static method calls where we call the method by class name. We are not interested in any particular object, and we are not looking at any particular object values. In our first example, we are saying integer.parseInt, and we are passing in the actual parameter of a string literal of 300. That method will take that parameter, it will look inside the string and get the integer value out of it, and so that statement will evaluate to the int value of 300. It doesn't matter if we had an object and what that object's value is, we are giving the method all of the information we need and it's going to give the information back. We do not need an object to use this method. In that case, we call it by class name. In our second example, we have integer dot number of trailing zeros, and we are passing in the int literal of 300. Again, we are giving it all of the information that it needs, and it will give us back all of the information that we need. This will evaluate to the integer literal 2 because there are 2 zeros at the end of our number. Finally, integer dot to binary string, we are passing in the value of 255. This will evaluate to 8 ones. So if we are interested in the member variables, we would call by object. If we just are using a method where we pass in the information that we need and it gives us back the values that we need, we are going to call that by class, and those are defined as static methods. So a static method, a method that uses no instance variables and can be called without an instance of the class. This aligns with our essential knowledge. Static methods are called using the dot operator along with the class name unless they are defined in the enclosing class. Our next concept is the math class. Our learning objective: evaluate expressions that use the math class methods. Math class is part of the Java Lang package. We already looked at some other classes that belong in this package. If we remember, the Java Lang package is included in all programs by default. So we have access to all of these classes. We can use all of their methods. We can create objects from them as needed. This aligns with our essential knowledge. The math class is part of the Java Lang package. If we looked up the math class at the Java API, we will see that there are a lot of math methods. Looking at these methods, every method in the math class is a static method, which means that you will never declare an object of the math class. This aligns with our essential knowledge. The math class contains only static methods. Our next concept is the ABS method. Our learning objective: evaluate expressions that use the math class methods. Looking at the math class in the Java API, we will see that the ABS method is an overloaded method. There are 4 different versions of it, accepting our different numerical data types. We are going to be looking at the one that accepts a double and returns a double, and the one that accepts an int and returns an int. Reading what this method does, it says it returns the absolute value of the value that is passed into it. So if we pass in a negative value, it will return that value as a positive value. If we pass in a positive value, it will just return that same positive value. Here we see some statements using that ABS method. In our first example, we are calling it based on class because this is a static method. We say math.abs, and we are passing in the int literal of -12. That statement will evaluate to the int value of +12. Our next statement, we are calling math.abs, and we are passing in 1.25 written in scientific notation. We are going to get back 1.25. We have overloaded versions of the abs method, one that accepts an int and gives back an int, and one that accepts a double and gives back a double. Now, in this case, the -2 did not come into play because that -2 is not part of the number. It's part of the scientific notation that tells us how to get the number that we want. Our third example has us calling the abs method passing in a variable instead of a literal value. In that example, num will evaluate to -12.111. Calling the abs method will evaluate to a +12.111. And in our last example, we have 2 variables. X is being initialized to 2, y is being initialized to -3. And we have an arithmetic operation being passed into the method. Everything inside the parentheses will be evaluated to a single value before being passed into the abs method. The abs method will only accept a single value. We have x plus y, which ends up being 2 plus a -3. That evaluates to a -1. That -1 gets passed into the abs method. That evaluates to a +1. If you pass a positive number as a parameter, you will get back the same number. This aligns with our essential knowledge that the abs method is part of the Java quick reference. One example of this in use is with the distance formula. Our distance formula is the absolute value of x1 minus x2. The reason we have absolute value is sometimes when you subtract x2 from x1, you get a negative number, but as we know, distance cannot be a negative value. Distance traveled is always going to be a positive value, in which case then you would need to take the absolute value of your answer. So we have x1 as -2.8 minus x2, which is 10.5. That evaluates to -13.3, but then we take the absolute value of that, so then your distance would be 13.3 units. Our next concept deals with working with exponentials. We are working on the same learning objective, evaluate expressions that use math class methods. We are going to be looking at two different methods from the math class. On the left, we are looking at the POW method. The POW method accepts two doubles, A and B, and it will return a double. The description tells us returns the value of the first argument raised to the power of the second argument. As we have learned, we do not have an operator for exponents. Using this POW method is how we are going to do exponents. POW is our power method. The value that we pass in for A will be the base. The value that we pass in for B will be the exponent. Again, both of those values will be doubles. On the right, we have our square root method in which we pass in a double value and it will give us back the answer as a double. It tells us that it returns the correctly rounded positive square root value of a double value. Now, there are some cases where taking a square root can get us into trouble. Like if we try to take the square root of -1, this is something that we do not know how to do in math. We just make up imaginary numbers to deal with it. If anyone tried to pass in a -1.0 or any value that is less than 0 into this method, it tells us that the result will be NaN, which stands for not a number. It also tells us that a special case is if you try to pass in positive infinity, then the result will be positive infinity. And if you try to pass in a 0 or -0, the result will be the same as the argument that you passed in. In our examples for our first statement, we are calling the POW method. We are calling it by class because the POW method is a static method. We call it by class and not by object. We are passing in 2.0 as our base and 3.0 as our exponent. This evaluates to 8.0. In our second example, we are calling the POW method and we are passing in 25 as a double for the base, and we are passing in 0.5 as the exponent. 25 raised to the 1/2 power is the same thing as calculating the square root of 25. That will evaluate to 5.0. In our third example, we are calling the square root method. We are calling that method by class because guess what? The square root method is a static method. We are passing in 121 as a double. That will evaluate to 11.0. In our fourth example, we are passing in a variable to the square root method. Num will evaluate to -12.0. -12.0 as a square root evaluates to not a number. Not a number is a special double value in Java. All of this aligns with our essential knowledge. The POW and square root methods are part of the Java quick reference. A real-life example of this could be solving the quadratic formula. There is a square root in the quadratic formula. The part under the square root is known as the discriminant, the b squared minus 4ac. We can calculate that discriminant using math.pow. Then we can use our square root method to take the square root of the discriminant. Moving on to our next concept, which is random. It doesn't mean we'll be talking about random things. We're going to be talking about one very specific thing, which still aligns with our learning objective, evaluating expressions that use math class methods. So think of a random number, any random number. Think of a positive random number. Did you guess 7? I'm thinking maybe you did. All right, this isn't some kind of magic trick to try to guess the number you are thinking of. This is an introduction to the random method from the math class. We'll see that it's static. It does not accept any parameters, but it does return a double. It tells us that it will return a double value with a positive sign greater than or equal to zero point 0.0, but less than 1.0. Here we see some examples of calling that random method by class. One time when we call that, it might evaluate out to this number, 0.7547 with a bunch of numbers. Another time we call it, it might evaluate to 0.984 something. A third time we call it, it might evaluate to 0.34 something. A fourth time where we call it, it might evaluate to 0.15 something. The lowest number that it will ever evaluate to is a 0.0. Now, it is possible that we will get that 0.0. The highest number that it will not evaluate to is 1.0. So we can get everything from 0.0 up to, but not including 1.0. The highest number that we would get is 0.9999 with all of the numbers being nines afterwards. We are going to start expressing these ranges in interval notation. If we see a square bracket by a number, that means that number is inclusive, which means that it is included in our range. If we see a parenthesis by a number, that means that number is exclusive and that number is excluded from our range. This all aligns with our essential knowledge that the random method is part of the Java quick reference. So again, here are some example values that we can get returned from math.random from 0.0 up to 0.99999, which makes the question, what good is this method if these are the types of values that it is going to return? If we look at those values closer, we will be able to identify them as the decimal representation of every percentage from 0 up to, but not including, 100. Which means to make this number useful, we can use it in a math calculation to help us get some numbers that we do want to use. Let's go ahead and call math.random. And whatever value we get, we will multiply that by 7, and then we will cast that as an integer. Looking at the smallest outcome of math.random, which is 0.0, 0.0 times 7 is 0.0, cast as an int is just 0. Which means if we ever multiply math.random times 7, the smallest outcome we would ever get will be a 0. Looking at the largest outcome, math.random times 7, math.random would evaluate to a 0.999999 something. I just used 2 nines to just shorten it up here. We multiply that by 7. That evaluates to 6.93. When cast as an int is 6. Which means when we multiply by 7, we will get an outcome in the range of 0 through 6 inclusive, which just happens to be a range of 7 numbers. This makes sense because we just previously said math.random will be every percentage from 0 up to but not including 100. Which makes sense. When we multiply that number by 7, we get every value up to but not including 7. Looking at it again, this time multiplying it by 22. On the smallest side, we will get 0 times 22, which is 0. On the largest outcome of math.random, we get 0.99 times 22, which then will evaluate to a 21. So when we multiply by 22, we will get outcomes in the range of 0 through 21 inclusive, which just happens to be 22 values. So when we multiply by 10, our range is 0 through 9, which is 10 different values. We multiply by 128, we can get all of the outcomes from 0 to 127, which is 128 different values. When we multiply by any number n, we will get numbers from 0 through n minus 1, which will be n number of values. Multiplying random by a number produces a range of values. So by using this math, we can manipulate the outcome of math out random to start getting some numbers that are more useful to us. What we saw then, if we want to generate random numbers in a range from 0 through 15, not including the 15, we would take math out random and multiply it by 15. What if we don't want numbers in a range from 0 to something? In our second example, we want a range of numbers from 10 to 25. We have now changed our code. We are still multiplying math out random by 15, but now we are adding 10 to it. Let's see what this is going to look like. First, on the smallest outcome that we can get from math out random. The smallest outcome is 0.0 times 15. That evaluates to 0.0. Once we add the 10 to it, that will evaluate out to 10. On our smallest side, we are getting a value of 10. On the largest side, math out random evaluates to 0.99. Multiplying that by 15 gives us our 14.85. Casting that as an int, that turns to a 14 plus our 10 that's been hanging out this whole time gives us a largest value of 24. Now we are generating numbers from 10 to 24 inclusive, which fits in the range that we said earlier, from 10 up to but not including 25. Looking at our examples, our first one we have math out random times 10. We're going to take that result and cast it to an int. We will get values from 0 to 9 inclusively. Looking at our second example, if we add 1 to that result, that shifts our range of values from 0 to 9 to 1 to 10. If instead of adding 1 to the result, we add 20 to the result, on the low end of 0 plus 20, that makes it 20. On the high end of 9, 9 plus 20 is 29. It shifts us up 20 values. If we subtract 5 from that outcome, that will shift us to the left. Instead of our low value being 0, our low value will be -5. And instead of our high value being 9, our low value will be -4. So adding a number to random shifts the range of values that we get, which then makes this formula very useful for generating a number in a range of values. If we are requested to generate random numbers in the range of 50 to 80, we have a range of 30 numbers, and they are shifted 50 from 0. In order to code that, that would be an int cast of the value math.random times 30, because that's the range of numbers we want. We want 30 different numbers. And then we're going to add 50 to that because we want those numbers shifted 50 from 0. In our second example, we want numbers between 10 and 20. Our range is 10. Between 10 and 20, there are 10 numbers, and they are shifted 10 from 0. This is the integer cast of the quantity math.random times 10. That's because we want 10 different numbers, and then we're going to add 10 to that to shift those 10 from 0. If we want numbers in the range of -15 to -5, that is a range of 10 numbers. From -15 to -5, that is 10 numbers. They are shifted -5 from 0. We'll have an int cast of the quantity math.random times 10 plus a -5, or you could just say -5. Our final example has a requested range of -3 to +2. That is a range of 5 numbers shifted to the left 3, so our shift is -3. An int cast of the quantity math.random times 5, which is how many numbers we want. That's our range of numbers shifted to the left 3, -3. This aligns with our essential knowledge. The values returned from math.random can be manipulated to produce a random int or double in a defined range. That's going to bring us to the end of this lesson. Make sure that you review how you feel about that learning objective. Read over your recap statements Hit me up with any questions or concerns that you have regarding these concepts. Join us in our next video and keep programming.